This is Algebra 2, Lesson 12.4, and today we're going to talk about phase shift. So I think this is the point where things can get a little more confusing. We are used to seeing a sine as an S shape in the middle. And we are used to seeing cosine as a cover hump in the middle, C shape in the middle. Now, the thing about phase shift is if I slide my sine graph over just a little bit, it's going to look like a cosine graph. And if I slide my cosine graph over just a little bit, it's going to look like a sine graph. And that's what we're going to do, is we can horizontally slide the graphs left or right to make it look basically like any graph we want. The way we do that, we're going to use the letter C for our parameter. Whether it's a sine or a cosine graph, we do x minus a number. You can still have an amplitude in the front, you can still have a period in the x, you can still have a vertical shift in the back. But we can slide a graph left or right by adding or subtracting however many degrees we want to move it with the x. And if you remember back to chapter 4, we talked about horizontal translations. It's backwards from what you would expect. So if you have a minus number in that parentheses, it's going to slide your whole graph to the right. And if you have a plus number in that parentheses, it's going to slide your whole graph to the left. So we would expect positives on the right and negatives on the left because that's how we graph on our x-axis, but the parameter in the parentheses actually makes it go backwards from what you would expect. So if I were to graph the cosine of x minus 90, I want to know what non-phase shifted function that looks like. So I do have a regular cosine right here. If I slide that to the right 90 degrees, it's going to go this way 90. To me, that looks like it's probably going to be a sine graph. I'm going to graph it to double check. So this was cosine x minus 90. And if I graph that, you saw me put in a cosine, it looks like a sine. And that's again because the regular cosine here shifted over 90 degrees and now it looks like a sine. Sine of x plus 90 here is a sine of x plus 90, and to me that looks like a cosine. So regularly the sine is here, but because we had a plus 90, it shifted left 90 degrees, and now it looks like a cosine. Let's try a couple more to see how they change. So we have sine of x minus 270. And looking at that graph, that also looks like a cosine. It was, yeah, minus 270. So regular sine is here. Regular sine is here, and minus 270 means we're going to go to the right 270. So regularly here, 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 that's where this piece moved to right here. And now it looks like a cosine. Cosine of x plus 90, let's graph that and see what happens. Looks to me like a negative sine graph. It's that S shape in the middle, but it's pointing downward. And sine x minus 180. Sine x minus 180. And I'll do the other one right away too. Cosine x minus 360. So here's my sine. That to me looks like a negative sine. And here is my cosine. That to me looks like a regular cosine. So the negative sine graph, I saw that S shape in the middle, but it was pointing downward. And 180 degrees is half a circle. So I basically moved that half a revolution. So that one makes sense. And this minus 360 one, 360 is a full circle. So if you move it 360 degrees, it's just going to fall right on top of itself. Okay, so now we have the ultimate challenge. We're going to try to write some equations. And we have to remember all of our ideas. We have our sine or cosine. We have our stretch it vertically. We have our slide it sideways. We have our stretch it sideways. We have our slide it vertically. That's a lot. So let's start with sine or cosine. You can pick, honestly, because we're going to slide these. You can easily turn a sine into a cosine or a cosine into a sine. So I'm going to go with cosine. Now, if I'm looking at a cosine, I'm looking for the top of the bump. I do think cosine is easier. If you're looking for a sine, you're looking for the middle, and sometimes it's hard to get exactly in the middle, but the top is a lot easier to identify. So I like doing cosines on these ones. So we're going to do some kind of cosine, some kind of number of bumps, some kind of sliding it over, some kind of sliding it up. To get the A term, we want 1/2 the max minus the min, 1/2 of 3 minus 2, 3 minus 1. Invisible 1, leave it off, put it on there. How about number of bumps next? I see 1 bump here. Invisible 1, put it on, leave it off. We're going to slide it over. So normally my cosine's right at 0. This cosine went here. And I'm going to estimate because I know that this mark is 90. So it looks like it's a little bit further than 90, or maybe right in the middle. I think it looks like it's right in the middle. So I'm going to go with 45 degrees. It did go to the right, so it's going to be a minus. Oh, not 90, 45. And then finally, the D is sliding it up. So we need my max point minus my amplitude. Okay, let's check this. I am going to leave off the invisible 1. Cosine. I'm going to leave off the invisible 1. X minus 45. And then I'm going to add 2 with my vertical shift. And hopefully that looks pretty much exactly the same as that one. Yeah, I think that looks really good. And we got one more. Again, a sine or cosine, it's really up to you. If we were going to look at sine, we'd want to identify this point right here. If we wanted to look at cosine, we would identify this point right here. I'm going to go with cosine. To me, I like looking at the tops, but you could identify it as a negative sine looking here, or a negative cosine looking here, or a sine again looking here, or a cosine again looking here, or a negative cosine, or a negative sine. You can look anywhere you want. I go with top of the bump, then I know it's a cosine. So, top of the bump, it's a cosine. Amplitude, 1/2. That is a 2. That is a negative 4. That would be 3. Let's jump to vertical shift. Max is 2 minus amplitude is 3, negative 1. So I can put a plus -1 or a -1 at the back. Next, we're counting number of bumps. Well, I just see one bump right there. So invisible 1, add it or leave it off. And then finally, we're going to do the horizontal or phase shift. So I'm going to erase this just to see it a little bit better. The top of the bump is here, which is not very far past. I know that this is 90. This is 45, so I'm going to go maybe 30. It's going to the left, so that should be a plus 30. Let's check. We have 3 cosine, invisible 1, x plus 30 minus 1. And that looks good to me. That is all I have for the notes. Good luck on the exercises, and please let me know if you have any questions.